Right, so in this video, we are going to talk about the origin of Earth, and there are four topics that I want to cover here. First is some of the early ideas on the origin of Earth, then some modern theories. What are the modern ideas? Then we'll look at how stars are formed. What is our understanding of the formation of stars? And then we discuss the high-level understanding of the formation of planets. So let's look at some of the early theories on the origin of Earth. Now, there have been a large number of hypotheses that were put together by different philosophers as well as scientists regarding the origin of the Earth. Now, the mathematician Laplace, he revised various ideas in 1796 and he formulated into something known as the nebular hypothesis. So this hypothesis considers that the planets, they were formed out of a cloud of material associated with a young sun, which was slowly rotating. Then sometime in the 1900s, Chamberlain and Moulton, they came up with a theory that maybe a wandering star approached the sun. And as a result of this, a cigar-shaped extension of material was separated from the surface of the sun, then young sun. And as the passing star moved away from the sun, the cigar-shaped material separated from the solar surface and continued to revolve around the sun. And it then slowly condensed into planets. Some other scientists like Sir James Jeans and Sir Harold Jeffrey supported this idea. Now, even at a later dates, the arguments that considered, of a companion of the sun to have been coexisting. So these arguments are also known as binary theories. However, in the 1950, Otto Schmidt from Russia and Karl Wenskar in Germany, they somewhat revised the nebular hypothesis, though slightly in different details. And they considered that the sun was surrounded by solar nebula containing mostly the hydrogen and helium, along with what may be termed as dust. The friction and collision of particles led to the formation of a disc-shaped cloud, and the planets were formed through the process of accretion. Now, moving on to the modern theories, that is, what did the scientists in the later period think about the origin of the Earth? Now, one interesting thing to note is that the scientists in the modern period, they more considered the problems of the origin of the universe rather than just keeping their focus on, how did the Earth or, how were the planets evolved. And the most popular argument regarding the origin of the universe, as you may already have heard, is the Big Bang theory. And it is also known as the expanding universe hypothesis. And it all started with Edwin Hubble in 1920, when he provided the evidence that the universe is expanding. As time passes, galaxies are moving further and further apart. And in fact, you can do a little experiment to understand this a bit better. If you take a balloon and mark some points on it to represent the galaxies. Now, if you start inflating the balloon, the points that are marked on the balloon will appear to be moving away from each other as the balloon expands. Similarly, the distance between the galaxies is also found to be increasing, and thereby the universe is considered to be expanding. However, you will find that besides the increase in the distances between the points on the balloon, the points themselves are also expanding. However, this is not in accordance with the fact. Scientists believe that though the space between the galaxies is increasing, observations do not support the expansion of galaxies. So just keep in mind that the balloon example is only partially correct. Now, moving on to understanding what the Big Bang theory is in brief. Well, the Big Bang theory considers sort of three stages in the development of the universe. Stage one was about the universe existing as an extremely tiny ball, right? So we can think about all the matter in this universe forming the universe existed in one place in the form of a very tiny ball with an unimaginably small volume, infinite temperature, and infinite density. In the stage 2 of the Big Bang, there was a rapid expansion, and it is agreed by scientists that this could have happened somewhere around 13.7 billion years ago. Now, this tiny ball that the universe was condensed into exploded violently. There's no reason why it happened, we don't know, but it just happened. And what is important is what really happened in the first few moments and the first few minutes of this Big Bang. The universe expanded so quickly, and it expanded very quickly in just fractions of seconds of the Big Bang. And atoms were formed within the first 3 minutes. Now, it is important to note that after that, the expansion has slowed down. The expansion of universe does continue to even today. And as this expansion kind of grows, the energy was converted into matter. Now, the stage 3 is when we can assume the formation of atomic matter. So what really happened was, within some 300,000 years of the Big Bang, the temperature dropped to 4,500 Kelvin, which then gave rise to the atomic matter, and the universe became transparent. So now let us quickly look at how the stars are formed. We can think about star formation in sort of 2 stages. First, we can think about the development of galaxies. Now, the distribution of matter and energy was not even in the early universe. The initial density differences gave rise to differences in gravitational forces, and which caused the matter to be drawn together. Now, these matters, these matters, these localized matter of bodies that form together, they form the basis for the development of galaxies. So galaxy, in simple words, contains a large number of stars, and galaxies are spread over so huge distances that we measure them in light years. Now remember that light year is simply the distance traveled by a light in 1 year, and a light year is a measure of distance, not time. So we know that light travels at a speed of 300,000 kilometers per second, and in 1 year light will travel about 9.461 into 10 to the power 12 kilometers. So you can see it's a huge distance, a very huge distance. And to put that into perspective, a typical galaxy diameter can range anywhere from 80,000 to 150,000 light years. So they are very, very huge. Now, after the formation of galaxies, we can think about the development of the stars. So we know that a galaxy starts to form by the accumulation of hydrogen gas in the form of a very large cloud, which is known as a nebula. Now, eventually, the growing nebula develops localized clumps of gases. These are just, gases concentrated in certain regions. And these clumps then continue to grow dense and dense, giving rise to more denser gaseous bodies, which in turn are the stars. And it is believed that the stars were formed about 5 to 6 billion years ago. Now let us look at the formation of planets. So the planets can also be considered to be developed in 3 stages. In the stage 1, what really happens is that there is a formation of a gas core. So as I discussed earlier, the stars are localized lumps of gas within a nebula, and the gravitational force within the lumps of these gases leads to the formation of a core to the gas cloud, and a huge rotating disk of the gas and dust develops around this gas core. So this is the stage 1 in the formation of a planet. In the stage 2, there is formation of small bodies called planetesimals, and the way it happens is that the gas cloud starts getting condensed, and the matter around the core develops into small rounded objects, which are known as planetesimals. And these small round objects, by the process of cohesion, they are just kept together, and that's what we call as this planetesimals. Now larger bodies from these small planetesimals get formed as well by collisions, which in turn then, due to the gravitational attractions, keep these together. So we can just think about this planetesimals as a large number of smaller bodies. This then leads us to the third stage, where you can, there is more and more joining of the planetesimals together, which is kind of the final stage, where these small bodies, join together to form fewer large bodies in the form of planets. So that was a really quick overview on the first unit, origin of the Earth.